Hello, my name is Chernyshov and this is Eternity Live Forum's interview with speakers who will perform at the forum at 11th of November 2022. Eternity Live Forum is a major event, a concentration of experience, knowledge and research from a number of scientists who will present the latest developments and ways to increase life expectancy and perhaps achieve immortality. So we are glad to welcome our viewers to an interview with an interesting person, great professional, PhD in biology and chemistry of aging, Francois-Xavier Pellay. Francois, what position are you currently undertaking in life extension?
So I am working as a founder of biotech companies, actually. I've been working for many years as a researcher, but now I started a skin rejuvenation company and also a supplement company and biotech. So this is what I do mostly now. Everything that I do has to do with longevity and aging, and my goal is to prolong healthy lifespan as much as possible.
Okay, great. So how do you think, is there any tangible progress in life extension research already?
Yes, I mean, there's, of course, past 10-15 years have been very, it's been a revolution basically in the world of aging. It's been a lot of change. We went from only knowing some of the basic aspect of aging to really starting to search for actual solution. There's quite a lot of new things that appeared over the last 10 years. Among them, the one that we hear about the most are senolytics. This is one of the big things that happened, 6-7 years ago, and this is something that was actually the result of course, other research that came from much before that, the realization that the cells were aging at different pace within the body, that some were getting older faster and becoming senescent and starting polluting their environment. This is something that we already knew for a little while. And then the idea that targeting specifically these cells would actually make the cell population younger by removing this the oldest component of this cellular population. So this is one of the things that went on and showed a lot of interesting results. It's also somehow related to research that were done for a longer time on telomerase. So we knew that telomere were shortening. Telomere shortening is actually the cause of cellular senescence. And so there've been some research. We're still, there are not so many molecules yet that can have an effect on reactivating the activity of telomerase enzyme. But clearly this is still a field, and these two are very much connected. So there's these two types of therapy, telomerase and senolytics, are therapies that target mostly the cells that divide a lot. And for the cells that don't divide so much or don't divide at all, like neurons and muscles, there's other therapy that have been developed for this past 10-15 years. A lot of therapy that have to do with autophagy, for example. So the rapamycin, for example, is one of them. It does other things, but among other things, it activates the cleaning mechanism of the cell, the autophagy, which will basically reverse to some degree the aging, especially in cells that don't divide, because when cells divide, they dilute their problem at each division. There's, for example, the protein aggregate will be divided by 2 at each division, but neurons don't divide and muscle cells don't divide, so they only can accumulate. So it's particularly interesting for that kind of cells to have that kind of strategy. Something that came up also quite recently was this everything that has to do with DNA methylation. So first, as a marker of aging, it's currently the best way to measure biological aging, and it's very important for research, for our understanding, but also for being able to screen for molecules. Knowing that we have effect on biological aging is crucial for what we want to do. And there's also the side effect, let's say, of the research on induced pluripotent stem cells, iPSCs, where we noticed, the scientific community, not me personally, that the cells that were treated through this way were actually rejuvenating. So there's also a whole pan of research that is going toward that direction. There's many others, but this is the main thing that comes to mind right now.
It's really great news that you are talking about. Everything is changing very quickly, and we have the new researches today. So how do you think, which technologies do you consider are the most significant for life extension?
Well, basically, I think that the biggest change will happen when we start combining this technology. So all the one I already mentioned are already like big change. There's also, my research personally was more on protein protection. So the possibility of slowing down the aging process by protecting protein against oxidation. I had a big pan of my research that was dedicated to that. I also worked on autophagy activators. That was something that I was very much interested in. I also work on mitochondrial protection because mitochondria are the one producing the ROS. So the reason why I went to so many directions is because I believe that for things to be efficient, for us to be able to slow down the aging process all the way to stopping it and eventually reversing it, to be able to do that, we will have to combine therapies because, like I said, we are very complex organism. We're composed of different kind of cells, of actually very complex systems. And so a single approach will never be enough. So combining therapies that target dividing cells, which currently is the main case, and combining therapies that target more the cells that don't divide and accumulate other kind of problem. This is basically the future. I believe that hopefully within 10 years we already can see results, but hopefully within 10 years we can double lifespan of mice, for example. That would be a really big achievement towards proving at least that we can really go further. And of course, the application to human as soon as possible, as long as it's not hurting us at all.
It's surely great. Do you believe that science and medicine are capable of achieving immortality for humans in the future?
And that's a good question. I have to believe, to be honest, because that's my main motivation since I started to be interested in the field. So in my case, it started really early. I started to be interested in aging and the possibility to stop it when I was still a teenager in high school. So that's pretty early. And yes, this is something, the reason why I went towards that is because I couldn't see a logical reason why it wouldn't be possible to stop it, like to stop aging completely or even to reverse it. Like aging shouldn't be a fatality and should be something that we do something against. So I definitely, I'm a scientist, so I cannot say I'm sure, but it's very likely that we are going to find a cure for aging. The question is not if, the question is when. So it's just a matter of time before we really get some solution to all of that. And it's going to be many solutions. It's not going to be a single one. That's for sure.
I really like a way of your thinking and totally agree with you. So which technologies do you think will support immortality most of all?
So beside the one I already mentioned, there should be more that will come in the future. There's something else that I haven't mentioned, is all the experiment on parabiosis. So this experiment where they link young mice and the old mice, and they show that the old mice was benefiting from being linked to the young one. This is an interesting, very interesting thing that we can learn from. And already, of course, there's a lot of things that have been learned from that. But basically, there's two aspects into that. First, that with age, we are missing stuff. So we're trying to supplement it. One of the examples is NAD+, for example. We can observe there's decrease of NAD+ with age. We take NAD+ precursors, NMN or others, and we see some improvement. So this is, let's say, the first aspect of trying to complement for what is missing. This is important, but also, and this is start only to appear, the fact that we should remove stuff also, because the body not just miss stuff, but also accumulate things that shouldn't be there. So some sort of cleaning mechanism on the outside, basically, like a dialysis system that would remove on regular basis all the things that we accumulate, will also definitely help. To go further, of course, we will need cell therapy to some degree. We'll probably need some gene therapy also at some, I'm talking about the future. I'm not talking about what is currently available, but yeah, I think that we should really explore every possible way. I wish that there were more, how to say, promotion of combination of therapy. If it was up to me, I would make a competition of scientists with, a little bit like this X Prize that Google made for, going to the moon. We could do the same for longevity by making a longevity prize in which 10 teams, of high level would compete to make mice, live as long as possible. And all options would be open to do anything possible to have mice would live, and this could be a 1-year contest in which you would follow the progress of each team, but making it into a competition similar to what Google did with X Prize. That could be a way to promote this. This is just an idea that,
Yeah, it's a very good idea. It's what we are planning to do also. It's our way of thinking. And the last question, in your opinion, what do we need to investigate more at this stage? Which technologies will be the most significant in the study of immortality for today?
Well, I basically mentioned pretty much everything that was going through my. On top of that, I don't think there's anything else that come to me right now. So this is
okay. Thank you. I've understood. We need to study all of this you mentioned. It was a really interesting conversation, and thank you very much, and I see you at the Eternity Life Forum.